Hello and welcome to my talk. My name is Atif Mashkoor. Today I'll be talking about validation obligations, a novel approach to check compliance between requirements and their formal specification. This is a joint work between Heinrich Heine Universität Düsseldorf and Johannes Kepler University Linz. Let's have a look at the table of contents first. First, we'll be presenting about the main motivation behind this work, followed by the proposed methodology. A brief introduction to rigorous method will follow that. Then we'll discuss about the case study that we have chosen to showcase the proposed methodology, and then the talk will be concluded in the end. So what is the main motivation behind this work? We all know that the use of our method is highly recommended for quality assurance of safety critical systems through various standards and guidelines. So what are formal methods? Formal methods are actually techniques for program specification, development, and reasoning about their correctness based on mathematics and logic. So in a typical formal method inspired development, we pick a certain set of requirements and then we model them using a rigorous language, and then we perform a series of verification and validation activities until the model is complete and correct and trustworthy. So we have observed that verification often takes the center stage in this process. For example, I can quote a lot of verification tools like COG, like Isabel, like NUSMV, and so on and so forth, FDR. But same cannot be said about validation. So we feel this is some kind of neglected in this domain, especially in stepwise refinement process. So what actually a stepwise model development process is? In a stepwise model development process, we specify requirements, a high-level set of requirements on the abstract level, and then using techniques like proofs, we can verify the consistency of the requirements, which means are we building the system right? And then through techniques like animation, we can also check whether we are building the right system. And then through the process of refinement, we can enrich the model by adding new behaviors and new data structures, which will again go to a series of verification and validation activities. But over here, apart from checking the correctness of recently introduced behavior and data structure, we need to ensure that the refinement also preserves the correctness and consistency with respect to the previously defined requirements. And then this process goes on and on until we reach to a level of implementation, which means the model is now complete and ready to deploy. So in a typical formal method inspired development, consistency of model is checked through proof obligation, as we just saw. So proof obligation is a logical formula associated with the consistency claim of a given verification property, which means that the verification of a specification is broken down into smaller steps associated with each refinement level, and then the total verification is the sum of all those proof obligations. Analogous to the idea of proof obligations, we propose to break the overall validation of specification and associate it with each refinement step following POs. So in that case, validation of the specification would actually be the sum of all VO's validation obligations that are associated with each refinement step. So VO's, for example, in this case could be an animation run, checking of an LTL property, or even checking of a trace. So we propose to realize the idea of validation obligations through the EVOAC approach. Over here you see a classical refinement approach in which abstract model is there, which is refined through a series of refinement steps. So at each refinement step, we can also associate different alternate stakeholders' views, which could be different abstraction. And these different and alternate abstractions could actually be validated by different stakeholders from their perspective through various means. For example, a human check of abstract state space over here. Another alternate view could also be instantiated, and we can replay a use case over here. And then all of these abstract alternate views could actually be the abstract model for the further refinement steps, which can again go to different validation checks. For example, through model checking, we can check generate a state space over here, which we can check for validation. And then we can also check temporal properties like LTL properties over here, and we can also again check some use cases replays over here. So we realize the idea of validation obligations and the EVOA approach through candidate formal method event B. Event B is based on set theory and first order predicate logic, and it enjoys a one-to-one level of refinement. Although stringent, it leads to a high degree of automatic proofs. It follows a correctness by design methodology, which means the model is guaranteed to be correct at the end of their development. It's old and proven, and it enjoys much industrial experience, and it also enjoys good tool support, especially for verification. So we apply the EVOAC methodology on an adaptive light and speed control system, and we see how it fares. So this is a very complex system. Over here you can see that there are a lot of small components which are crucial for this system, like brake, like accelerator pedal, like beams, infotainment system, and so on and so forth. So it's really a complex safety critical system. More detail about this case study can be found in this work. So as I mentioned that this is a really safety critical system with a lot of components, and we don't have time to go through all of those components and requirements. So just pick one requirement and let's see how our approach fares with it. So the requirements we have chosen to demonstrate is about the pitman controller, pitman arms behavior, especially during the blinking scenario. So here is a visualization of the scenario that we have chosen to demonstrate. Over here we can see that okay, these are the model elements. We can play with them manually, or we can just run a predefined or pre-recorded scenario or use case. So first we switch on the ignition, and then we can see that when the driver takes the right turn, then the lights on the right shall blink. Look, see how they are blinking. And when the driver takes the left turn, then the lights on the left hand side shall blink. So they will blink in a second. So just wait a few more seconds. So here it is. And then user can also turn on the hazard lights. For example, the hazard lights are on, and yeah, so this is the whole scenario. So in the end, we can say that the cost of failure is high in safety critical systems, and when the human lives are at stake, then they become even unacceptable. Verification and validation are equally important activities, so we believe that they merit equal attention in formal method development. And this is our humble effort to propose EVOAC methodology, which puts validation in the center of refinement-based development. We achieve it by proposing validation obligations, which can provide like POs-like semantics to the concept of formal validation. So in the end, I would like to invite you all to submit your work on AI and software engineering. Are we ready? This is a special issue for IEEE Computer, whose deadline is 30th of July 2021. So with that slide, I reach at the end of my talk. Thank you very much for your patience, for listening to me. And if there is a question, I'll be happy to take. By the way, sorry for the background noise. It's Sunday, I'm at my home and my children are playing in the home. So sorry for that. I hope I was audible and understandable. Anyway, if there's a question, I'll be happy to take it. Thank you very much once again.
Welcome back to the live session, dear audience. So, this presentation was about formal methods. And whenever I don't fully understand what's going on, I have a conversation with my rubber duck. A rubber duck is always a good thing to have handy when you're not entirely sure if you've understood somebody else's research. So I just explained it to the rubber duck, and then we take it from there. But we're not going to do that right now because we have a bunch of interesting questions in the chat. So welcome, Atif. And your first question by Bashar is, I wonder if you can say more on your use of the term obligation. For proof obligations and verification, there are correctness criteria that are precise and formal. However, for validation, are we building the right system? The notion of correctness is a discussion, negotiation process with a customer. It seems to be that you're dealing with design specifications and not requirements.
Yes, thank you very much. Very interesting question, actually. So the idea is the same, like how actually somehow formalize the notion of validation as well. And we are trying to borrow the same principle as provided by the proof obligation stuff. For example, we can come up with some validation obligation or validation task that we can try to formalize. Now think of a trace, or think of LTL property which we can prove. So our idea is that we can state the validation obligation as, for example, now I'm giving you an just example of LTL property. There could be some other applications as well. So LTL property could be expressed as a validation obligation, and then we can kind of show that, okay, eventually this property has been met. And that could be our kind of uh, not proof, but kind of a validation obligation that we have just shown. So we are using the same principle provided by formal verification like PO, but we are extending the boundary to the validation domain. I
Mhm.
hope it answers the question. But just sorry, adding one or more that could be a use case replay, a trace replay,
Mhm.
um, an animation run. So there could be some other possibilities which we can reason about.
Okay.
Does that answer the question?
I believe it does. And Martin Glintz was asking along those same lines. And if I can take Martin's question and maybe make it even a tad more informal, because he asked, how can formal obligations be used in informal validation with stakeholders? I was wondering, um, like, are we going to tell the client, I automatically validated that we built the right software for you? Of course, like that sounds slightly cynical. So my question is, as we go back to the stakeholder and say, hey, we already did also this formal validation of where we're trying to head, like how do you communicate that back? Like how does that stand in relationship with the informal validation with the stakeholder to check whether it meets their needs?
Okay, so when we talk about a formal validation, it means a mathematical and logical formulas, which
Hmm.
may require to build a mental image in order to perceive what that mathematics and logic is actually portraying.
Hmm.
Now, think of if we provide operational semantics to that mathematical formulas or logical formulas, we can actually animate. By animate, I mean, can we execute the specification and can we show the actually what the user gonna get in the end? Now with that we take away the mental modeling effort of the stakeholder away, because now we are seeing what you see is what you get. That is the actual live specification.
Hmm.
Now proving a property of that, again think of a scenario. A train runs from here and wants to go to Dusseldorf, for example, which is, by the way, our partner university. And in order to say a temporal property, again, I'm providing you a temporal property. Can the train eventually reach Dusseldorf? And we can show some traces, we can show some counter examples, we can actually show some use case scenarios. Look, in those scenarios, our end result or end state was eventually reached. And that could be a validation obligation.
Okay, and how would that come back in when you talk to your customer? Like when you do the system acceptance with the customer, the informal validation with the stakeholders. Like I understand what your approach is doing and how it's putting it into the formal simulation, even, and that's great. So would you then come back with your simulation and say, here, the customer, we've shown that we are fulfilling all the use cases, or in Bashar's words, when a validation obligation is not met, does it mean that the requirements were maybe wrong?
Okay, now again, very interesting.